So harmonic drives, you guys ever heard of these things? I found out about them probably about a year ago, and I thought they were really cool. They're kind of in a similar space to cycloidal drives. Their main benefit is they offer a high gear reduction in a small compact area. So that's one of the reasons why they're used a lot in like CNC machines and also in robotics, like big robotic arms for industrial uses and things like that. The harmonic drive, which can also be called strain wave gearing, was initially introduced in a patent by C.W. Musser in 1957. The core design of modern strain wave gearing remains identical to what Musser laid out in his patent. However, modern gearboxes are made more efficient by using bearings and high-end materials to reduce resistance. Harmonic drives have three core components: the circular spline, which has inward-facing gear teeth; the flex spline, which typically has two less gear teeth than the circular spline, so it has a smaller diameter and will fit within the circular spline. And then finally there is the wave generator, which is placed in the center of the gearbox and distorts the flex spline enough that its teeth mesh with the circular spline. The wave generator is rotated by the input of the gearbox, and as it turns, it deforms the flex spline. Since the flex spline has two less teeth than the circular spline, every rotation of the wave generator, the flex spline rotates by the angle taken up by the two teeth. This means that the equation for the reduction ratio is the flex spline teeth minus the circular spline teeth divided by the flex spline teeth. As you can see, the gear reduction value is negative, which tells us that the direction of rotation is reversed at the output when compared to the input. Since harmonic drives are primarily used for industrial purposes, they're typically pretty expensive and really hard to find. So I wanted to design my own that I could use for personal projects in the future, as well as it could be applied to pretty much any type of hobby project. I decided to design two different harmonic gearboxes. The first is a little bit larger and heavier duty. It has a hub on each side so it can be easily attached to pretty much anything you want. And by using bearings on all the rotating surfaces, these gearboxes have a relatively low resistance considering the input to output ratio. The second gearbox has a slightly smaller design and is also a little less heavy duty than the other one. This gearbox is designed to be mounted in the front of a stepper motor. By using a gearbox like this, a smaller stepper motor can be used for higher torque applications. For this harmonic drive, the white 3D printed parts are all made out of PLA plastic. However, the yellow internal gear is actually printed from PETG. This is because the internal gear needs to flex a little bit without cracking. Initially I tried to print the entire gearbox using PLA. However, after a lot of use, the internal gear would start to crack, so I switched to PETG and I haven't had any issues since. So as always, the bearings and hardware I used for this project are basically stuff I just had laying around. But they're all really straightforward to find on like Amazon or anywhere. These are common bearing sizes. And if someone else wanted to use a different size of bearing, then they could pretty easily just change the CAD and it would probably work fine. For this smaller harmonic drive that mounts directly to the motor, the white 3D printed parts are again made from PLA. However, for this gearbox, since the inner gear has to strain a lot compared to the inner gear diameter, it needed to be printed from a more flexible material like TPU. Now I know what you guys might be thinking, Michael, don't you have a Bowden tube extruder in your 3D printer? You can't print flexible filaments. That's illegal. You need a direct drive extruder to do that. Well, guess what? It worked just fine. I found that the key to a successful TPU print with a Bowden tube extruder is to basically just print at a little bit higher temperature, and then make sure that you get one of the brands of TPU that's a little bit stiffer. Typically, if you read the comments on like the listing for the filament, people will say whether or not it works with a Bowden tube. Thank you guys so much for watching. I have done a bunch of testing on these Harmonic drives, but I haven't done any like max load testing yet. So I think we're going to do that in the next video, so stay tuned for that, subscribe, whatever, and I'll see you then. Peace.